The following is a presentation of NoVA Hackers at ShmooCon Epilogue 2014, hosted by Mach37, brought to you by ComputeCycle.
So my name is Will Schrader. I go by the handle Harmj0y. I'm a former National Research Lab keyboard monkey. I come from a kind of straight CS background. I've been interested in breaking stuff for a long time, just like I'm sure most of you probably are or have been. And about a year and a half ago, started getting really interested in the idea of doing Evasion research. Started from not really knowing anything. A few months later, teamed up with this guy, another developer, Michael Wright. And a year or so later, or even under a year later, about 9 months or so later, this talk and the current Veil framework is the culmination of all of our efforts.
I'm Chris Truncer. I used to do technical documentation and hated it, so quickly got out of that role. Then moved into a sysadmin role, got a fairly solid technical background, and was lucky enough to be able to get a job doing pen testing, and figured out that that's what I love. I've been doing that since. Mike Wright is our third developer. He unfortunately is not here, but he's the guy that's been in charge of basically any usability stuff that Veil does and its design and everything, or UI if you will, has largely been a result of his work. So he's really tried to make it fairly easy to use. All of us work as pen testers for various group, and whenever we can, we try to do as much research at night, if you will, on different AV evasion tactics or anything really. So we'll talk about kind of what we're going over today. The first thing, it's basically us discussing our problem that we had. A lot of pen testing firms and companies or individuals that go out and perform pen tests have this problem of evading antivirus. I'd be really impressed if you found an environment that you didn't have to evade AV, because that would be an interesting setup. But basically, a lot of your payloads are currently getting caught by all the different solutions that are out there. If you look on our next slide, we'll actually be showing virus total, and it's just showing everything that's getting caught. So we tried to come up with a different solution that we could use to not have this problem anymore, and that resulted in Veil Evasion. It's our AV evasion tool designed to create payloads that bypass as many different AV solutions as possible. And we'll also go over a quick demo on that. So our next thought was, okay, we have the start of a tool. Let's try to turn this into a framework that can be utilized by other tools as well. And so we wanted to figure out, okay, what's our next extension of this Veil framework? And so we have our payload generation. So the next logical step or thought for us was, okay, how do we deliver this payload to the different target machines that we're going against? That resulted in Veil Catapult, which is our payload delivery tool. And so we'll also be given a demo on how you can use that to get your Veil Evasion or your custom created executables onto a target machine. And then finally, we'll also discuss what are the different methods that you can use to try to stop Veil Evasion or Catapult to prevent this from taking over your network. So our problem, like we said, is AV. The different solutions out there are catching stock Metasploit generated payloads, which is what a lot of people commonly use as their foundation, if you will, for trying to generate a payload that bypasses an antivirus. You'll see right here, this is just a stock Metasploit generated payload that's caught by 35 out of 48. So we're talking about a pretty significant amount of antivirus solutions that are catching it. So you can't utilize this functionality on your assessments because you're going to get caught and it's not going to work. So our problem is, because we're getting caught, we're having to spend more and more time on assessments trying to figure out different ways to bypass antivirus. And so you're having like an assessment overhead, if you will, versus actually performing your assessment on the network or the operating systems or their domain environment that the client has set up. So we want to try to figure out how can we not have this problem anymore so that our time when we're actually on an assessment is more valuable to the customer. We wanted to have our solution, or we brainstormed and tried to figure out a couple different attributes that our solution should have. The number one thing is we think our solution should try, or our goal is to try to be able to have us bypass antivirus as easily as professional malware developers can. Malware exists. This is obviously nothing new. They have great capabilities. Like, they're constantly able to bypass the different solutions that are out there. whether this be straight signature checking, maybe some heuristical analysis. We wanted to try to be able to come up with some sort of methodology that will allow our payloads to also bypass AV solutions as easily as professional malware developers can. We didn't want to have to roll our own backdoor for every single assessment. If we were to do that, obviously you're just wasting time on every assessment, and that could be better spent assessing the system. So that wasn't an option for us. We wanted to have or try to create a reusable framework and payload if possible, but also make it different every time so that it's not a static signature that could be developed for that one instance of that payload. And finally, one of the most common ways to actually get a backdoor on a system is typically through the execution of shellcode, whether that be your own custom shellcode or Metasploit framework generated shellcode. It's one common method of doing that. And so we want to try to figure out how can we execute this shellcode, obviously malicious in nature, but in an AV evading manner. So our solution, like we stated, was Veil Evasion. This is our menu system, or that you'll see. You can see right now there's 24 different payloads that are currently loaded into the framework when we took this. There's a bunch of different commands in there, and we'll go over some of them later on. So our approach was, when we initially released this tool, and I believe almost a solid majority of everything that we have right now is all drawn from publicly available research. This stuff is already out there. We didn't even necessarily have to come up with almost any of it at all. It was just a reuse of different techniques that various people have put in blog posts or GitHub pages or anything like that, and have been utilized across multiple different languages. So we wanted to try to take all these available techniques, create them in a framework, and make it in a method that we can quickly generate new payloads based off of those techniques at any sort of instance that we want. Our main focus point was, like I said, to automate the payload generation process, so you could basically just run a quick tool and it would make it for you instantly. So you didn't have to spend a large amount of assessment time, again, going over this or creating the payload, and then the usability of the tool. And in my opinion, I can't use a tool on an assessment if I'm afraid it's going to fail on me. It would be unreliable and I wouldn't be using it. So we wanted to try to account for as many different error cases and anything like that would cause unreliableness, that's not a word, in our tool, and account for them so that it wouldn't happen. And then finally, we also wanted to create, there's this idea of being able to create stage 1 payloads, if you will, that call back to a Metasploit in a higher level language such as Python or C that don't actually require shellcode. And so we wanted to be able to have that sort of payload available to our framework as well. When we did this, we had a large number of internal debates whether we actually should release this or not. We kind of went back and forth for quite some time, and then we felt that the best way to handle this is through public disclosure and just fully releasing it. We'd like to think that releasing it outweighs the benefits of not releasing it. Additionally, I kind of feel, or it was really largely shared by us, that professional malware developers are already ahead of most of us, or the white hat community in general, in their techniques that they use to bypass AV or perform whatever sort of actions they want on victim machines. So we thought, if the bad guys can already do this, why shouldn't the good guys have the same capabilities of them? The goal is to have us better emulate these threats, if you will. So we want to have the tools to let us carry out that task. It kind of closely aligns with the exploit disclosure debate, we feel like, at least. H.D. Moore basically stated that the benefit of releasing this information obviously outweighs, in his mind, the risk of not doing so. And while this isn't the same as necessarily releasing an O-Day for some product, it's creating a technique, or it's releasing a technique that can be used in a malicious manner if not controlled. So our take, we obviously chose full public disclosure. We wanted to help our industry try to better emulate these threats as much as they can. And the big thing that kind of led us that way is our source code is publicly available. It's not closed source. Anyone can get it. It's free. So AV vendors can currently see everything that we're doing, all the calls that we're making and attempts for obfuscating or encrypting our code. So if they really wanted to, they have the capability of seeing exactly what's being done, and they can attempt to try to write a signature for whatever our payloads are. Our public reaction, we released this on May 30th, and these are actual comments from our Reddit post, and it was interesting because we got hit from a couple of different areas. Certain people didn't like it at all. You could obviously see which side of the fence they lean on the disclosure debate, and other people's did. So we had mixed fanfare, if you will. After releasing our Veil Catapult, our Twitter reaction was that it bothers people that pen testers will never know they'll have to do this manually. And you can see a couple people had the same ideas as well.
Yeah. Those are our favorite quotes from the Twitter flurry right after.
Didn't one of those guys help or do power exploit?
Yeah. Chris Campbell is power split.
Yeah.
I mean, he was saying, we were hoping you saying it was yes. We took this as actually a very good compliment.
joke.
That was my favorite tweet. So the Veil framework. Again, we've expanded the framework a bit more beyond just a single tool, but the original genesis was Veil Evasion. So I'm going to go over that very quickly. So the features for Veil Evasion. One of the big things that we had requested from the original tool was the ability to utilize any Metasploit generated shellcode or custom shellcode and the variety of payload modules we have. So what we actually do is we'll crawl the Metasploit install tree, snarf up any of the potential MSF payload module options for Windows only at this point, and we extract out of the files all the associated options, if it's lhost, lport, whatever the specific things are. And all this, it happens transparent to the user. And we'll go over here in a little bit how shellcode is actually abstracted out. So if a module invokes shellcode, a user has access to any of the stock Windows MSF payload or MSF Venom payloads currently in the Metasploit framework. We also have the ability to integrate third-party tools through Hyperion, which was talked about a couple of years ago, I think publicly by Dave Kennedy. It's a self-brute-forcing AES PE crypter where it'll wrap up a current PE or a current executable, decrypt itself in memory after brute-forcing the key. PE Scrambler, which is just a specific kind of packer and obfuscator. And the Backdoor Factory, which is written by Josh Pitts, who actually comes to NoVA Hackers here. He's a fellow NoVA hacker. It's a cool tool that lets you take custom rolled shellcode that he kind of has tweaked out and hide it in code caves and existing executable. But we set it up to where you can very easily integrate these types of tools into modules straight into the framework. We also have command line switches, and the big for I think almost every single option. And the big push here was we want you or any other developers to be able to integrate Veil Evasion into their own projects. And we also, like the module tree, one thing I forgot to mention, the module tree and everything like that. If you have your own payload modules, you can just drop it straight into the structure like you would the Metasploit framework. They're loaded up, and as long as everything's structured correctly, then you can take advantage of all the compilation, all the current obfuscation and everything that we have. So just kind of as an example we had, if you want to integrate it with third-party tools. So Harmj0y, which actually Raphael is off teaching his class right now using the paid version Cobalt Strike. But Harmj0y is essentially a GUI for Metasploit. It's pretty cool. It's open source. You can get it in Kali. And Cortana is a attack scripting language they released a couple years ago at DEF CON that lets you control certain actions, extend things, integrate tools, modify menus, and whatever you want in Harmj0y or Cobalt Strike. So we released inside the source a Veil Evasion Cortana script that exposes a nice little graphical menu that lets you control everything in Veil Evasion. And you can also choose to have the payloads hooked into all the PSExec calls. So transparently, we try to make this as easy and transparent to your workflow as possible. To where if you're on assessment, you can use the GUI to generate a particular EXE, have it hook all the PSExec calls, and just go on like normal without having to worry about any AV snarfing up anything. And there's a link down here from Rafi's blog about releasing Cortana, real-time collaborative hacking with bots. And these slides are posted on our main website, or they're posted on SlideShare. And we have a link from our main website, which we'll tell you here at the end if you want to get a reference later. This is a quick example, so we won't be able to go over it in the demo. I can actually use this maybe. Whatever. Up here, like where it has payload and everything, if you double click this, it'll dynamically load up all the current payloads in the framework. You see the Python, and like later on there's some C# stuff and some C and PowerShell and things like that. MSF payload will actually load up a bunch of, it'll give you several options that you can load up. I think we have the reverse TCP, reverse HTTP, HTTPS, and that type of stuff. And here you can choose to set it as the current PSExec payload. You can reset that and all that. If you have existing listeners, you can actually pull those in. It'll fill in all the configuration information automatically. And you generate it, and it'll give you an executable path if you want to use it manually, or it'll automatically save that off if you want to hook the PSExec calls. The native compilation, this is kind of the meat for the framework. So our big push here is we wanted to have a single monolithic attack platform, and the de facto is pretty much Kali at this point. So we don't want to integrate any kind of language or approach that we can't produce a Windows executable natively on Kali. So for Python, the two ways you generally tend to do this are either with py-to-exe or PyInstaller, which fundamentally work pretty much the same, but py-to-exe is, we could only get it working on Windows, so we stuck with PyInstaller under Wine. This will wrap up a Python file, the interpreter, all the associated libraries, all into a self-extracting executable. When you run this, it extracts everything to disk and invokes the interpreter with your particular script. So a couple of years ago, I think popularized by Dave Kennedy again, people started realizing you could use this for pen testing. And it's great because some legitimate executables actually, or legitimate projects use this, like Dropbox, I believe. So AV vendors can't just flag on the little loader at the front because it actually is used by legitimate projects, which is probably why this approach, even though it's been known for several years, it's still effective. It still gets by almost everything. And, you know, it kind of shows that static signatures are dead.
It's ginormous, right?
Yeah, the disadvantage is it's extremely large. It's around ours between 2 and 3 megs, which makes it a pain in the ass for PSExec calls in certain aspects. Yeah, if you can't get by with other methods, it's a good fallback, but it's a good point. For C#, for any machines that you want to deliver to that have .NET installed, Mono can be installed on Kali, lets you compile C# and VB.NET. And for C, we use the MinGW package. So again, all this stuff, we want it compilable on Kali and then runnable on Windows. So this is the fun stuff. For module development, if you want to implement your own obfuscation methods or own approaches, we want to make it as easy as possible for you to do so. So we have lots of reusable functionality. We have cryptors, obfuscators, randomizers, all the kind of fun stuff that you would expect. And shellcode generation is abstracted out. So you can just import a little shellcode module, invoke an object, and then just ask it to generate itself. And the framework will take care of all the back end, extracting out all the options, doing all the validation, prompting the user for everything. And it'll just spit out a nice user customized shellcode string with whatever options the user wants. We have a payload template in the framework right now that shows you how to fill in whatever options you want. And you can do things like specify manual options to where if you have a pure stager, and you want a user to have to import an lhost and lport and things like that, you can force them to do so. And we have a pretty extensive payload development tutorial on our main website, veilframework.com. I think that's about it. Yep. And again, you can just take whatever modules you create, drop them into the kind of little framework tree. It's divided by language and approach, and it'll load straight up right into the tool. So am I getting caught? A lot of people like to test their backdoors or payloads on VirusTotal. If you don't know why that's not a bad idea, which hopefully you do, is if there's a single positive trigger on any of the engines, then VirusTotal, right in the terms of service, they tell you they do this. They take the sample, distribute it to every other engine participating, every other vendor, and tell them, hey, someone thought this was bad, maybe you should check into it. So if you want to submit all your backdoors, it's your prerogative, but it's going to diminish the lifetime of the particular approaches. So a better way to do this is to check the hash of your particular exe against VirusTotal to see if someone submitted it. So what we do is we keep a running hash list of every single payload generated by the framework under Veil output hashes. And then we use Rob Fuller right here, his VT notify script. We have a slightly modified version of it that we integrated in, so we can send one command. It'll use an API key and call VirusTotal's API and check every single hash you have against it, and it'll alert you if any of them have been submitted. This is great for red team engagements to where, you know, if the start of the engagement you're using this tool, you can keep a running list that you reset at the end every time. And at any point you can check and then tell if any of the payloads that you've generated have been submitted by the customer, as if, you know, if they're starting to get onto you or not. And that link is Moose's original VT notify script. This is just an example of the interface. This is all on the back end now. You just type check VT, it spawns up all the hashes, and it tells you here this payload with this hash has been submitted to VirusTotal. Okay, shellcode injection. Most of the methods used by Veil at this point, they fall into one of two categories, either native stagers, which we'll talk about a little later, or different shellcode injection techniques. There's three main ways to do this. There's probably more, but these are the ones we utilize at this point. So you can either cast a raw chunk of memory, like an unsigned character buffer as a void function pointer, invoke it, and it'll just jump execution straight to that. The disadvantage here is you have no guarantee that that particular memory region is executable. So depending on depth protections and things, which we actually talk about in the next slide, this method might fail. And the classic method, and I think this is the one used by most of the Metasploit shellcode, is they use a pattern where they'll use virtual alloc to allocate a big chunk of memory, use a few other API calls to copy it in, or copy your shellcode into that memory, you create a thread, and then you wait for it to finish execution. So that way you can guarantee that the memory region is executable. So there's also another way that's not as highly utilized, but it's known but not as highly utilized, is you can use heap alloc and like heap create and heap alloc to manually create a heap object, copy the shellcode in, and do the same kind of approach. And if you guys want any more details or stuff on this, you know, hit us up on our IRC channel. We're on Veil on Freenode, or hit us up by email or Twitter or anything. We'd love to talk about this stuff. So dep and PyInstaller. We ran across a weird bug with some of the Python stuff to where some of the payloads would succeed if you just ran the Python file manually on a host. But if you had a PyInstaller produced payload of that exact same one, it would fail. And it's because PyInstaller produced EXEs opt into data execution prevention by default. And this ruins like the void pointer and some of the other shellcode injection methods. So even though dep is designed as an exploit mitigation technique, the fact is, you know, if we're not manually specifying that area of memory is executable, then it'll fail with an access violation. So luckily, PyInstaller is open source. You can recompile the loader to turn dep off, and you can get a more functioning loader that can do different, or, you know, a wider range of shellcode injection techniques. We have a big detailed post about exactly how to recompile that and turn that stuff off.
So different payload releases. We came up with this concept called V-Day, where it's kind of like our victory over antivirus, if you will, where we're trying to basically kind of model this off of Microsoft's Patch Tuesday, where every month we're going to be releasing some new technique that can be utilized by the Veil framework. So this could be its own payload, or just adding a different tool or something like that that will expand the functionality of the tool. Currently we have 24 different payloads or techniques that bypass AV within the framework, and we have 20 or more additional payloads that we are still testing, QAing, and getting set up and finalized for addition into the framework. So we're planning on releasing stuff for quite some time. So I said before, we wanted to figure out how to do shellcode list stagers. This is already a solved problem. We just wanted to figure out how we can do this or add this functionality within Veil. Rafi created a post on how he does his own sort of loader, and it's basically your stage one interpreter load or executables don't have to be implemented in shellcode. You can utilize higher level languages such as C or scripting languages, Python, to act as your stage one executable and receive the interpreter DLL from your handler. So we chose to do that. Right now there are payloads for C, C#, and Python. The main difference that you'll see here for C is interpreter TCP service is designed to be a valid Windows service binary. So when you use psexec, it'll actually run correctly, since that's going to be obviously standing up its own service. The other payloads are all working for their specific type of interpreter stager, or callback, if you will. And we just released Python-based HTTP and HTTPS this month, I believe it was. So how it works is your higher level, or basically your stage 1 executable, the first thing it does is it creates a TCP connection back to your handler. So typically, this is obviously going to be your Metasploit framework listener. The handler then sends 4 bytes to your victim machine, which indicates the length of the DLL that it's about to transfer over it, and then it sends the actual DLL 99% of the time, the system interpreter. The socket number is then stored in the EDI register that was used for your communication, and this is the socket number that the raw OSO, in our case, we only have Windows Payload, so the socket number that Windows sees it as is stored in the register. And then once the DLL has been transferred, execution is passed basically right into the DLL, just like shellcode, just as if shellcode were actually in the spot. And the reason it can do that is because the interpreter DLL was designed to be specifically reflectively loaded and have this capability. So let's go over a quick demo on how Veil Evasion, how to use it. So let's pause this. Go ahead. Okay, go ahead.
So Chris is just going to show really quick, if you haven't done this, hopefully most of you have, just using MSF Venom.
Oh, shoot.
You just skip that part.
Yeah, all right, we're just going to skip.
All right, whatever.
Well, MSF Venom gets caught.
Yeah, so that is what we showed in Shmoo for a wider audience.
So this is the Veil Evasion menu. Obviously right now we have 24 different payloads loaded. In order to check the different payloads that are loaded into the framework, you just type list. And you can see we have our C, C#, the different tools that are standalone tools are available, and then PowerShell and Python. So in this case, we'll also use the AES encrypting payload. So in order to do that, you can just type use, and you can tab complete the whole thing, or just give it the number, and that'll load it up. These are the required options that Will had talked about before. They already have a current default value, so we don't really need to set anything for this specific payload, and it's fine as it is, so we can just go ahead and tell it, okay, keep these options, let's generate our payload.
And one thing you can see there we added into, forgot to mention, was you can actually set a lot of the Python ones to expire. So if you're on engagement and you only, you want to kind of do some potential damage control, you can basically say these payloads will only be valid for the next week. After that, if they trigger and it's past a certain date, they'll just kill themselves.
Yep. So I'll execute. In this case, if you have custom shellcode that you want to use, you can specify right here. But I'd say most of our use case by a lot of different people, they just use MSF Venom. And so we'll stick with,
and that part there where it's Windows Interpreter, you can actually tab complete off all the, if you want to do reverse HTTP or HTTPS or anything, and that's the part where we crawl off the tree and try to extract everything.
Yep. No, you're fine. So we have our IP, our local IP, and our port we can set. And if we have any other extra options that we wanted to set, you would set that right here. Otherwise, you can just enter past it, and it's generating our shellcode right now. And so we just give it a name, so don't catch me. And so this is invoking PyInstaller. Py.exe, if that was going to be used, it would generate all the files that you would need for that, but you would obviously also have to have a separate Windows platform in order to use that.
Yep, you need a copy of it.
Yep.
Explain what it is.
So this is our handler script. The Veil will auto set up a Metasploit resource file that you can invoke it, which I'll do right now. And what this is going to do is it'll auto set up the handler for our payload that we just generated. And so all we need to do is basically deliver the executable to the target machine, and then we can, we'll already be listening for it. So let's see. So here's our executable.
Just drag it to that side.
Okay, so let's find our Windows machine. We'll just use this one. And we catch it on.
It's Windows 7 MSE.
You try to scan it. It'll come back as clean. And then if we run it, you can see we're getting our session back. So it's bypassing everything right now. Good.
There we go. All right. That's what we should have known at ShmooCon. Yeah. Play from current slide. Okay, so we spoke about trying to make Veil an actual framework beyond just the original tool. So again, this is our Veil Catapult, our kind of payload delivery system. What we mean by that is if you have current legitimate credentials for a machine, how do you get your executable onto it and get it fully loaded into memory and running? So like the most classic example of this is Metasploit's based exec module, but again, because it uses well-known stock templates that they don't really try to obfuscate because they know it's a cat and mouse game. Another well-known example is SMB exec, which uses patch Samba binaries and a patch version of WinExe, which is the Linux version of psexec. They use the Samba binaries to upload and then WinExe to trigger. But we wanted to build something that tied into Veil Evasion really tightly and covered a few of the gap areas which we felt might be missing to get a few ideas. So it ties into the existing code base. You can, as payloads are released for Veil Evasion, everything will be loaded up. We'll show you in the second demo the full interface. We also produce cleanup scripts for Veil Catapult that will kill any processes and remove any payloads that were, kill any process and remove any payloads because we want to leave a client's machine in a pristine state. We don't want any artifacts left on disk. And again, with the theme we kind of want to keep standard with the Veil framework, we want to have command line flags for every single option, which got kind of extensive for this tool. There's 20-something flags on it already, even though it was just released less than a week ago. But we wanted you to be able to take full advantage of all its capability without having to go through an interactive menu. So again, this is a quick interface. We'll show you in the demo, but we have some standalone payloads, which we'll talk about, exe delivery, cleanup, all that fun stuff. So exe delivery. Users can invoke Veil Evasion to generate a payload on the fly. You actually drop into the full menu, just that Chris showed, or you can specify your own custom rolled executable. And payloads are delivered in one of two ways. You can either use the Impacket library, which is a Python-based SMB library, to upload the executable to a machine. And then we use one of two options from the passing the hash toolkit to actually trigger execution. We use the WMIS, pass the hash patched executable from the passing the hash toolkit, or the pass the hash WinExe, which is again the kind of the Linux version of psexec. So WIMS does not create a service, so it's a bit more stealthy. You're less likely to be caught. But the WinExe executes a system. So kind of depending on your environment, and your approach, and your kind of level of risk, you can choose which one you want to use in a particular situation. It defaults to WIMS. The second approach we have is you can actually host the executable on your machine using a temporary SMB server and use a UNC path back to your machine to trigger the exe. And this will load the exe almost directly into memory. And the neat little trick with this is it gets otherwise disk detectable EXEs right by a lot of antivirus vendors. So we'll show this in the demo to where if you have an EXE that's caught on disk, you can use this. At least we haven't tested with every AV vendor, it's a new tool, but it'll actually load up and you can get a session. An interesting thing that we discovered though is that while some EXEs that are detected on disk you can use this for, if you use a stock MSF Venom stager that's produced by the Metasploit framework, Microsoft Security Essentials will catch this at the process ID level. So they have some kind of in-memory signature specifically for the Metasploit stager, kind of showing again that they're trying to stop pen testing tools without actually doing proper behavioral detection, which they should be doing. Standalone payloads, most of these, or at least PowerShell, has been well known, it's been well used, everybody's liked it for a few years. We in no way invented this. This is at least where I originally read about it, and there's probably resources before, but from the Exploit Monday blog. But you can invoke PowerShell binary with a particular argument string and inject shellcode right there without actually having to touch disk. The bare bones Python approach we'll talk about in the next slide, but it uploads a minimal Python installation and uses it to invoke shellcode. And the setHC backdoor, I think this is Rob actually talked about and is added as the new black. And when he gave it here at NoVA Hackers, okay. It can issue a registry command to set the debugger for setHC, which is a sticky keys thing, to be or the end result is when you try to log into RDP and you hit shift 5 times, you can get a command running a system. And we have scripts to clean that up as well. So bare bones Python. This is kind of our interesting little slightly novel approach. We have a manually tuned or kind of pruned and stripped Python environment. It's zipped up. We upload that along with the 7-zip binary. We issue a command to unzip the whole thing in the temporary directory. The only things that touch disk are trusted Python libraries and a trusted Python interpreter. This is known. It's not caught by antivirus because people use this all the time. And then we use this -c command to invoke a minimal Python program just like you would PowerShell. So no bad logic touches disk. This gets right by a lot of reputation filters and antivirus. It's the same kind of trusted execution model as PowerShell, but we still run across systems, old XP systems, or whatever else that don't have PowerShell installed. Sometimes PowerShell is blacklisted at GPO level, so Julie would like to have this additional little option that we thought was kind of neat. So demo 2, I'm speeding up because we're losing time. Let's see, this is Veil Catapult. What we'll do is if we click exe delivery, we'll, oh wait, did I do this first? Okay, we'll drop straight into the Veil Evasion menu. And what we're gonna do is use this C shellcode virtual inject void. This is about as basic as you can get. It's detected by almost everything. It's almost a stock MS Venom template. We're going to leave this, all the stock options that we already saw. Come on. Okay, here we go, payload. I'll show this. Oh no, it's ripped out. Blah, blah, no threat detected. Okay, so these 3 machines here, we have a Windows XP, x86, we have Windows 8.1 with Windows Defender. All these are updated as of Friday. We have Windows 7 64-bit. What we're gonna do is when we click enter here, we actually just added this in yesterday. It's you can turn this off if you want, but it'll auto spell on the handler script. Just like SED and SMB exec and all that fun stuff. Oh, you already have it running. That's why. Okay, whatever. Then I have these IPs already here. You can provide a domain. You don't have to. JSmith has the awesome password to password. You can also do LM and TLM hashes, WMS or WinExe. And here's the host or upload and execute. If we host it, we have to give it the IP so it can reach back properly. And when we press enter, it's going to be there. It's going to set up the SMB server, host it, start triggering all the payloads. Oh, come on. Why is it? Oh, man. It's the worst demo ever. What? Whatever. Let's try. Okay. Ah, crap. All right. Sorry. This is going terribly. One more time.
Wait, was that it?
Yeah, that wasn't it. That was the old one that I forgot to close, so it still had the port open. Here we go. One more time. Okay, here we go. Handler going. Let's see if this works.
There we go.
Yay, sessions from all machines, straight into memory, without touching disk. Thanks, MSE. Yep, okay. There's the XP 8 and 7. Okay, so that's how you can get disk detectable stuff right by lots of antivirus, which I thought was cool.
Was that all using the same Python one?
That was actually, it was using like C, just like a void function pointer. So like, here's the shellcode, jump to it, and that's it. So, and that was the same executable dragged on the disk. Okay, so how to stop us really quickly in 5 minutes. We promise we're not trying to hand out fully functioning cyber weapons to all the bad guys. We know it's a really hard problem. We've thought about this a lot. It's very easy to kind of wage asymmetric warfare against the AV vendors, but then again, they also have millions of dollars and lots of people, and we don't. So predictable behavior. A lot of malware and veil evasion payloads have a pretty kind of standard set of behavioral patterns. There'll be immediate reverse connection to a target, TCP or HTTP, rewrite, execute memory page allocation, binary code copying, thread creation, that kind of stuff. So usually a pretty small set of APIs are used in a specific and non-standard way. So this is a great behavioral detection opportunity that apparently they aren't doing properly. So ambush IPS is one free way that you can stop this. It's a intrusion prevention system that was released a couple years ago at B-Sides Las Vegas by Script Junkie. It allows for very flexible rules to be written for API calls. So you can say like this call with this particular argument in this way, and then this call, and you can chain these together and do these awesome rule sets. The end result is you can stop every single interpreter stager on a machine without affecting execution of Internet Explorer or something like that. The website is ambuships.com. And Emmet, people have been harping on this. Rob harped on this. Everybody should be using Emmet. So even though it's more of a, obviously like an exploit mitigation toolkit, a lot of the mechanisms it has stop the ability for an executable to inject shellcode. Kind of ties in with a lot of the rot mitigations and stuff they have. So if you want to block virtual alloc for read-write memory allocation, those types of things. So people have talked about using this in an enterprise for, say, Adobe, for, say, Internet Explorer, and all the typical kind of targets that you might get entrance in. Nobody's talked about, that I've heard, so I apologize if somebody has, but if you enable PowerShell, this will ruin shellcode injection and ruin a lot of tools and make stuff very, very hard. So even though you can't enroll arbitrary executables, so you can't stop all the other veil payloads, you can stop our PowerShell approaches, and you can stop the PowerShell approaches of a lot of other tools as well. The link down there details Emmet, and everyone should go install it if you haven't. So I'll be the 8th person to say that.
So the last real part, to find any sort of information that you want on the Veil framework or any of its tools, you can hit up our website. We try to have as many different blog posts as we can as possible, some bit on basic tutorials and usage of the different functionality of our different tools, or guides on like how to perform, like do your own development of your own payload module. We're also in Cali. That's a manual process on getting that updated every single month, so we constantly work with them. But in order to make sure you have the latest version of it, check out our GitHub page. That's where we commit everything to, and that's where the Cali latest versions are staged from. So that's what we recommend.
And actually right there, so we have separate repos for Veil Evasion and Veil Catapult, and we're going to keep a continually updated master branch or super project under Veil Framework Veil, which will pull in all the tools currently in the framework. As we release others, we have some more ideas. So if you're a normal user, install it from here, run the update script, it'll do everything for you. It'll install dependencies, it'll install PyInstaller and PyCrypto, it'll install Patching the Hash toolkit and all that fun stuff, and get all the settings going.
Yep, and so we know there's a lot of different technical stuff, so if people have any questions or maybe you want something explained a little bit better, you can hit us up on email, Twitter, or we have forums, whatever you want, or just come talk to us, because we love this sort of thing and talking about new techniques. So that's about it, unless there's any questions. Awesome. Well, thanks for having us.
This has been a presentation of NoVA Hackers at ShmooCon Epilogue 2014, hosted by Mach37, brought to you by ComputeCycle, video recording and streaming services provided by Cranial Thunder Productions.